My name is Branch House.
I'm Fulbert Young.
I'm Alejandra Perez.
I'm Gianna Pistola.
I'm Carlos Flores.
We're Team Alpha, and we'd like to present to you COMS.
And so for COMS, we're comparing our system to the GAS Alert Micro Series and the Dual O2 CO2. If you notice, both of these products have the sensors that we are using, which is carbon dioxide and oxygen sensors.
First of all, what are you guys doing overall? What's your system meant to do?
So we're developing a small modular air monitoring system. The system should measure both CO2 and O2 continuously in enclosed areas and give an alert when the levels are toxic.
So going back to this slide, if you see for the pricing models, the GAS Alert Micro Series is $770, and I started because its base price is $500, but the moment you start adding sensors such as like oxygen and carbon dioxide, that price actually increases. Same thing with like the low power. It is low power, but if you add any of the rechargeable batteries, it'll also increase the price. If you notice for the Dual O2, the price is extremely expensive compared to RG, which is only $350. It is not portable, and it is also not low power, but it does include the sensors that we are using. And then for ours, it's portable, it's low power, and we're using the necessary sensors for the system.
So our goal is a worker in a wine tank. Once fermentation is over and our cleaning, we'll be able to stay in there as long as possible. Currently, the way it works is somebody goes to the front of the wine tank, takes their meter, checks, and the person enters and cleans it. This does not give continuous readings, which is a problem because levels start to change. It only gives an initial reading. So columns can easily be placed on a wall, and while the worker is working, the levels are being checked. And as soon as the levels are no longer safe, as according to OSHA, we will then alert them so they can exit safely.
So this is our release board. That's our PCB board without the enclosure. As you can see the sensors, the battery, the PSOC, and the battery connectors. The one on the right is our board on the box we are using, and we're gonna mount the box to the wall inside the wine tank.
And this is an image of our current setup right now. As you can see, we have a cozier and O2, and they're just mounted. Currently, there's also a base plate, so for better mounting.
So this is how our power works. We charge our battery through a battery charger, and we just use a micro USB, the same that you would use in your phone. The battery is 3.7 volts, and after the voltage goes through the battery charger, it supplies the regulator with 3.3 that outputs 3.3, and the boost that outputs 5 volts. And the regulator with the 3.3 supplies the cozier and the PSOC, while the 5 volts is for the O2 sensor, the Luminox.
So this is our digital communication system. We have PSOC communicating through UART to cozier. We have an Luminox oxygen sensor, and we are driving the buzzer with a pulse width measurement.
So these are the two sensors we decided to use. On the top left, we have the cozier, which measures the carbon dioxide. That goes for about $110. As you can see, it's very low power. Using our battery, the 2500 milliampere hour battery, just the sensor alone can last up to 1500 hours on it. And for the oxygen sensor, we have the Luminox oxygen sensor. That goes for about $50, $60. It's also low power. The warm-up time is a little high, so that's why that sensor would be on for a little bit longer. But actually, forgot to mention, the CO2 sensor would be only running for maybe the 3 seconds every minute throughout the day, as long as the thing is on, and that's why it lasts so long. The luminox oxygen doesn't need to be measured as much as the carbon dioxide, so that'll be on every 2 minutes or so. But again, the warm-up time is a little higher, so it does last 300 hours just for the sensor alone on the battery we have. So this is the state machine. Again, the sensors will mostly be idling, and then so as you can see, every minute carbon dioxide will be measured, and then 2 minutes pass by according to the timer on the encoding. Oxygen will be measured, and then immediately after, carbon dioxide will be measured. And then if those levels are reached, those unsafe levels are reached according to OSHA, we'll have the buzzer turn on and alert continuously to get the worker out of harm's way.
So unfortunately, despite the sensor alone having such a long timeline, the full system itself will not be able to last like 1,500 hours. So on the top, you see 3 cycles of sampling. Every 2 peaks is 1 cycle. The reason why there's 2 peaks is because we have to look at a 2-minute interval. In the first minute, we have the PSOC turn on and the CO2 only. So in that, you end up with about 43 milliamps. In the second minute, you turn on the PSOC, the CO2, and the oxygen, which then increases it to about 76 milliamps. And it keeps repeating like that every 1 minute and 2 minutes. Now, in the case where the levels are no longer safe, we have a buzzer. So here, as you can see, it peaks up at about 102 milliamps. That is because the buzzer itself takes about 30 milliamps of current. And over here on the graph, you see that it's continuously high. While the levels stay toxic, the system will continuously buzzing to make sure that the user understands that it is no longer safe. Once the levels drop, after continuous reading, the current goes back to 0. Overall, our system is generally, the power consumption is through the 2 sensors and the buzzer. Each take about 30% of power, while the PSOC itself only takes about 13%.
Greatness of working in an enclosed environment such as winery and brewery is the constant changing of carbon dioxide and oxygen levels. This can easily affect the worker's health before they are ready to act, often leading to grave consequences.
This is COMS, the first step in revolutionizing air monitoring for any work environment.
Many systems today allow you to monitor only a single gas in the environment, and in the cases when multiple gases are monitored, the cost can be unaffordable. With this in mind, we designed COMS to reach the balance between cost and quality.
This little device continuously monitors carbon dioxide and oxygen levels, always making sure that a healthy and safe environment is maintained. With its built-in alert system, COMS will let you know when carbon dioxide and oxygen levels are approaching unsafe trends.
Make your work environment a safer place. COMS, air you can breathe.
And we'd like to thank Cypress, Texas Instruments, and UC Davis College of Engineering for making this possible. Any questions? Yes.
How would you plan on mounting this on the side? Like you said, you would mount it to the wall of the line tank. Obviously, you can't screw it into the wall.
Yes. So we're looking at different possibilities. One could include Velcro or even strapping it on the person themselves, maybe to the back or a helmet of some sort. We're working at different possibilities to figure out a proper mounting system for that.
So why didn't you use magnet?
Because stainless steel isn't magnetic.
So there's 1 minute between measurements, is that right?
Yes.
So how long does it take for someone to like asphyxiate? And if that's less than a minute, then something might spike.
So the way we have it set is at around 5,000 parts per million, the user can start seeing signs of dizziness. So our alert starts at around 4,800. And the levels will not rise like 2,000 to 3,000 in that short span of time, so we're safe on how we're sampling.
Along those same lines, how long does it take somebody to actually clean those tests?
I'm not sure, but we're assuming an 8-hour day.
What was the question?
How long does it take for somebody to, like, once they enter one of those wine tanks to finish cleaning it?
I mean, it would depend on different sizes and things like that. but we were basing our timeline on an 8-hour day.
I can easily be in 30 minutes.
Yeah.
How did you calibrate? Why didn't you explain a little bit how you calibrated the scenes of?
Sure. So we had two different ways we did it. One, we have another system that's measuring CO2, and we benchmarked it against that as well to make sure that our sensors getting accurate. Secondly, we went down to the winery itself where they have a calibration gas. So in that way, we know what the parts per million of that gas is. We put it in an enclosed box and set the gas through it, our system, to see what kind of readings we were getting. And when we looked at it, it was exactly what we were expecting. So we know that our system is functional.
Okay. Any other questions?
Yes.
Yeah, I noticed everybody seems to be using the same universal, I guess, casing for it. Did you guys have to adjust your board so it fits in that casing?
Yes.
So was your initial board different before you got that casing?
The only square centimeter size itself wasn't that different. The only way was the shape itself. So instead of making one a little thicker and smaller, it's longer and thinner.
So how many board revisions did you guys do to get to this point?
We had 2 alphas, 2 betas, and now we have our final. So 5 total.
Is that kind of on average with all of the groups here?
Yeah.
Yeah.